Welcome back. So video number 2 of our furnace series. Last video we looked at all the components. Today we're going to actually do some component removal and reinstalling. Start out, just wanted to again acknowledge the local HVAC team. Not the HVAC group. I think last video I mentioned that incorrectly. Local HVAC team, localhvacteam.com, got me this furnace when they took out as part of their work, and I was able to get it from them, and I think it's going to do really well. So thanks to them. I got Ben behind the camera doing the video for me, so thanks Ben for doing that. And let's see where we go today. We're going to start taking some components out. So I want to start with the burner. So this burner assembly here, it looks kind of stuck in there, but really, if this gas pipe was actually connected, that would have to be undone first. So obviously, you would need wrenches to do this in the real world. So it's got a union here. Technically, I think the union should be outside the cabinet. My recollection is not 100%, but I'm pretty sure code says that the union has to be outside the cabinet. Again, don't quote me on that. You have to look at your code book for that. So gas piping is disconnected. Boom, just like that, done. So that's the gas pipe disconnected. So in order to remove this, there were tie wraps on here. I took the tie wraps off and I just put some twist ties on to make things a little bit easier for me. So this wiring harness has to be removed, not removed, but just loosened from the manifold here. In order to remove that, I'm going to have to take the 2 wires off of the gas valve. So I've actually, not a bad idea when you're doing this, take pictures. Okay, so before you start pulling wires off, get out your camera, get out your phone, get out your camera, take a picture so that when it comes time to put these wires back on, you know where to put them. Yes, you can go to the wiring diagram, it's going to tell you where to put them, but it's a lot easier. You just go to your phone and look at your picture, and it tells you where those wires came from. I'm just going to undo the pressure switch here, undo the pressure switch here just to get them out of the way, so that we don't have that stuff in the way. So it's pretty much ready to go there now. So I'm going to get these are 1/4 inch screws that are in there. So let's take those out. Number 1, number 2. And boom! Burner assembly is out. So gas valve right there. You will see on the manifold 4 orifices. Those orifices will be put back into these burners. The burners are a little bit tricky getting out. They're wedged in there pretty tight. So maybe I'll take 1 out, but I'm only going to take 1 out. Like I say, they're a little bit fussy getting in and out. So maybe I won't take one. Oh, there we go. So there's the burner right there. Venturi right there. Burner end. So this is where your flame's going to be. Your air and your gas are going to mix in here. Flame's going to come here. I'm going to pop that back in. Boom, just like that. These happen to drop down as soon as you take it out. A little bit of a nuisance, but it is what it is. So I mentioned before that I'll show you the igniter. This happens to be a hot surface igniter system. Tip number 1, hot surface igniters do not touch with your fingers. Hot surface igniter right there. When 120 volts is applied to this hot surface igniter, this igniter glows red hot. and that's what actually lights these burners, the hot surface igniter. Could be a spark. Some furnaces have a spark. Some furnaces have a glow coil type thing. This is this is actually ceramic. The black part there is actually ceramic, and dropped my screw. There's a little spot there. I'm suspecting that this hot surface igniter might actually have a little crack in it. There has to be continuity through this hot surface igniter or it won't function properly. So I'm just going to go pick up my screw. So that is the igniter, the hot surface igniter. We'll put that back in. So one screw holds that in place. Remember, they are somewhat delicate, so you do want to be a little bit careful with those. They are ceramic, they can break. Not crazy expensive, but... And then on this end is the flame sensor. We'll just get in there, take the flame sensor out. There, flame rod. These are a good idea when you're doing maintenance. You just pull these out, give them a little clean, little sanding. This senses whether there's a flame or not. Flame rectification. We're going to go through later on, for those of you that are in my class. We're actually going to go through the manual. This you can test these with your meter. It's a millivolt reading that you're looking for. There's a certain way to do it, but it's important that the flame sensor is working properly. If there's a flame and this doesn't sense it, your furnace won't work. If there's no flame, if for some reason the igniter happens, but the burners are plugged or whatever, this will sense that there is no flame, shut the furnace down. It's a safety control, so that's what its job is. Pretty straightforward, and again, not too difficult to get in and out. Just gonna get this in there, find the hole, take it back up. And away we go. Take the wire back on there. The limit switches, again, 2 limit switches here. If for some reason the burners are plugged, flame starts coming back towards the front of the burner instead of going through the heat exchanger. These limit switches sense that and they will trip. They are resettable. There's a little button on them that you can press to reset it. You don't want to be pressing the button over and over and over again. If they trip, there's a reason that they trip. Those are like flame rollout safety switches. This would be a heat exchanger limit switch right here. If the heat exchanger gets too hot, if the blower quits or whatever. I did mention there was also one more limit switch underneath here, similar to that, or with a reset button on it. So 4 limit switches, all safeties to shut the system down if for some reason something is wrong. So let's put this back on. So 4 screws basically hold this burner assembly in place. It's a little bit tricky. So what I've found is you put the 2 screws in the top first, and you've got a little bit of a lever action there because these burners need to be pushed back up so that the venturi is back onto the orifice. So a little bit of a trick there, getting that sorted out and getting them all in place. Here is getting the 4th one, and then the other 3 don't fall out. You'll notice that this furnace is up on a stand. Generally, you're not going to do this in this position. You're usually going to be down on the floor. So I have made this a little bit easier for me to demonstrate. But generally, this is going to be on the floor of the basement. And you'll figure it out one day. So there, our burner assembly is back in place, ready to go, all put back together. Now I would reconnect my piping. Okay, I've got my 2 wires for the gas valve, put those back on. I put the wire back on the flame sensor, so that's good, and I would reconnect, just connecting these wires back up again, or not connect them up, but just fasten them up so that they're not flopping all around, keep things neat and tidy. It's always good to have a little bag of tie wraps in your truck, because you're not going to be using twist ties. In the real world, it just makes it easy for me so that I can take it off and put it back on again and not have to cut them. So that's the burner, in and out, done. Some things you're going to look for is dirty burners. Look into the heat exchanger. Do I see any sooting, any plugging, anything like that? So again, this looks pretty clean, not such a big deal. So that's the burner in and out. Then I'm going to reconnect my piping, get that done. Get my pipe wrenches out, tighten that union up nice and tight so it doesn't leak. And we're set to go there. These pressure switches, I mentioned that before, their function is, if you've got your vent connections here, your exhaust going out, your combustion air coming in, fresh air coming in. If for any reason any of these was plugged, your burner's going to be messed up terribly. Your flame's going to look really bad. Your heat exchangers are going to plug up. There's going to be sooting. There's going to be all kinds of problems. These pressure switches will sense that there's something wrong here, and it does happen. They get frost build up in the wintertime, animals build nests in them. I've seen them with leaves in them. I've seen pretty much everything. People put furniture and stack them up against the vent pipes, plug them up. This has to exhaust. This has to suck air in. If this is pipe, this has to suck air in. If not, your combustion process isn't going to work properly. So these do sense that. So I did want to actually show you one of these in action. So I'm not sure if the camera will actually. These actually sense negative pressure. Now they don't sense positive pressure, they sense negative pressure. I'm going to pull these wires off. So you will see, I'm going to turn my meter on here, and I don't know if you can zoom in on that. If you have a look at the meter there, it says OL, open loop. So there's no circuit. I connect my meter to that, I look for continuity. Oh look, no continuity, nothing's happening. If I blow on this, nothing happens. If I suck on it, you can see that I actually get continuity. So as soon as there's some negative pressure, the switch closes, I have continuity. So as soon as this Venner motor starts, these switches sense the negative pressure, send a signal to the circuit board saying everything's okay, we're okay to fire up. If they do not make a circuit, the circuit board will say, nothing's going to happen, something's wrong, we're not going to have a flame. That's what these switches do. So basically just an open-close switch, very simple. But they are safety switches, and their purpose is if any of these plug up, if the heat exchanger plugs up, if this Venner motor stops, if for some reason the motor is no good, plugs up, something inside breaks, whatever, if this induced draft motor doesn't run, there will be no negative pressure on these pressure switches, and you will not get a flame. It will not go through the flame starting process. Okay, so that's the pressure switch. That's when connected back over here. Oh, that's actually that should go through there so it doesn't run on top of the motor. But I'm actually going to disconnect those again anyway, because the next thing I'm going to do is disconnect the venter motor. So, anyways, let's hold these off again. So, venter motor, induced draft motor right here. If this quits, could be a number of reasons. Could be the motor failure. There is a wheel inside there, a blower wheel. If the wheel breaks, whatever. I think I mentioned before, these come as an assembly. Generally, you're not going to repair this unless it's an absolute emergency. You need to get something going. So I need to just loosen. There's 2 gear clamps here I need to loosen. They're still loose from when I did my test run before, so that's okay. I've got 4, 1, 2, 3, 4 1/4-inch screws. 2 long ones, 2 short ones. This assembly here, I don't think that's in the well. I'll move that hose too. I don't think I have to, but I will. So this condensate hose here, just gonna squeeze that together. The other thing I need to do is I have wires connected here, so I need to make sure those wires are disconnected. So ground wire under a screw, and these are just, you just pull these apart, and my wiring is disconnected, right? This is generally, this was a ring connector. To make things easier, I just nipped a little bit off the top just so that it's easier for me, because I'm taking it apart, putting it back together, to just get it back under the screw. And this is now loose, so I just wiggle it back and forth a little bit. Bam! Venter motor assembly is out. You can't really see in there too well, but it's like a little blower. This turns, the motor turns, blows the air through, sucks the air in here through the heat exchanger, sucks it through here, blows it out here. So motor, wheel, a number of things can go wrong with this. And again, generally you're going to buy this as an assembly. Just you take one out, put the other one in. You're not going to take this apart and repair motors or replace motors. You can if you're really in a real bad pickle, but generally you're just going to replace the whole assembly. While this is out, have a quick look in here. Just look for any damage inside. If you see any sooting in here inside the heat exchanger, you should maybe note that, but this looks fairly clean. And that's your venter motor assembly in and out. Again, pretty straightforward, right? It's not really that difficult. To put it back in, you had a new one, you're putting it back in. Just going to put the discharge in there. Trick here is to get these holes lined up properly. Again, 2 short screws, 2 long screws. So I get those started. those two, them started, and we should be. Just put them in far enough that, no, I wouldn't, like, don't tighten everything down yet. Let's wait until everything is in place. Number 3, 4. Now we can start tightening things down because we have all 4 screws in place. Snug it down. You don't have to reef these really, really tight. There's a rubber seal in there. So if you tighten them too tight and you crack the housing, you're going to be into a fairly expensive. These Bender motor assemblies are not cheap. You don't want to be causing any undue concern for yourself. So there we go. And maybe I should do this now because I didn't do it before. Just tighten these gear clamps so I have a good seal. Connect your wires back up. Ground wire. Connect to the cabinet. And my 2 power wires here and here. White to white, black to black. Pretty straightforward. And I would be good to go there. So now I'm going to reconnect my condensate line. Spring clamp. Push it back to where it's supposed to be. Bend. There. And my 2 pressure switches back to where they're supposed to go. Again, think, oh, how do you know where to connect all these hoses? Well, you know what, take a picture. Again, like I said before you start, take a picture so that you know this. When you've got this hanging and you go, oh crap, I forget where I took that from, then you can look at the picture and you can see where you took it from. Okay, so next will be the blower. So a little bit more complicated, but not ridiculous. The trick here is we've got some wires in the way, so we have to identify which wires are going to be in the way. And this blower is actually held in place by 2 screws from the bottom. So let's do the wires first. So I see, so those, whoops, this connector pin on the circuit board. It's a white connector pin, has a whole bunch of wires. Has to come off the circuit board. This is probably the easiest one because it's pretty easy to identify, but in order to pull that off, squeeze those 2 tabs in this whole connector. Will pull right off, and I put that over to the side. Don't think these 2 wires, the limit switch wires, are going to be in the way. So this limit switch, the whole limit switch, I remember I mentioned there was a limit switch down here, it just snapped into place. It's in the way for the blower to come out, so it has to actually take it out and put out of the way. Power wires, red and black right there, just take them off. So this black wire has to come off, and these neutral white wires need to come off. Now, and my transformer wires, I think that once I take these transformer wires off, I should be My blower should be free and clear now to come out. So, 2 screws underneath. If you can't see from the top, you can actually see them sticking up from underneath, but a 1/4 inch. If you have your 1/4 inch nut driver, you just take them out from the bottom. One. Take this one out from the bottom. Number 2. We're getting 2 screws out. This blower assembly will now slide right out. Just like that. So there's my complete blower assembly. Blower motor, blower wheel, wires, capacitor, run capacitor right there, and here you can see the circuit board. The bottom of the circuit board here is my thermostat connections. So in electrical class, hopefully you would have gone through that, the one lab on thermostats. You've got a Y terminal, W, R, G, C, so you would know that 24 volt power is R. Heating signal, W. Cooling signal, Y. Fan signal, G. C is common, so depending on, like, do I have a programmable thermostat, do I have a mechanical thermostat, what do I need to see? That's where your thermostat connections will connect to. You can see this transformer looks a little worse for wear, it looks pretty rough. That's why I'm thinking there may have been some water in here. That's just by the looks of that. The other thing to identify on this circuit board is this blower motor is a multi-speed motor. And if you're to look in the wiring diagram, you'll actually see white wires common, but there are actually 4 speed wires. I get to choose which speeds I want to run. Me, the service guy, the installer, whatever. So black is high, red is low, blue and orange are in between, medium high, medium low. I didn't notice this before, but they have low speed on cool. Generally, you're going to find that cool is better with high speed, especially with a multi-story house. If it's a single-story house, not such a big deal, but a multi-story house. Remember, cold air is heavy, warm air is light. So it's easier for me, I can use a lower speed for heating than I can for cooling, generally speaking. So I've got these 4 speed wires. I have to pick where they're going to go on this circuit board. They're going to come from the factory preset, but I have to pick. You will also see that there's 2 terminals. You probably can't see it, but there's 2 terminals up here, and they say park, park, and park. Because I'm only going to use 2 speeds. 1 speed for heating, 1 speed for cooling. I have 2 extra wires. So those 2 extra wires that I'm not using, I park them on the park terminal. Then I've got a terminal that says cool, and I have a terminal that says heat. Okay, so I'm going to put the low speed on heat, and I'm going to put the high speed on cool. So now I've just set up my fan speeds where I want them. If I find that those speeds don't meet the requirements that I need, I can change this pretty easily from the blower. I don't have to take the blower out to do this. I can do it just with the door off, but you want to make sure the speeds are set properly. The other thing you will notice on the circuit board is this little LED light, which is going to tell you some information. And you're actually in the lab, you're actually going to answer some questions on if the light's doing this, what does it mean? If the light's doing that, what does it mean? So I'm not going to get into that right now because it's actually going to tell me whether the power is normal or whether there is a fault. The circuit board senses if the limit switch opens, if something else happens, the circuit board actually senses that and will send a signal to the LED saying blink, 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 something's wrong, and tells me what the fault is. So you really don't even have to be a rocket scientist to figure it out, because the blinking light will tell you. I just noticed something here that may have been an issue with this furnace, in that this Stacon, the wire wasn't crimped properly in that Stacon. So could have been an issue, because this transformer might not have been getting the proper power that it should have been getting. So that's obviously somebody didn't crimp that properly. So another little takeaway there. Okay, so now to put this back in, I generally find, so you're gonna, if you remember, while this is out, have a quick look at it. Remember, squirrel cage blower, right? It's called a squirrel cage blower because it looks like a squirrel hamster wheel. But while this is out, have a quick look at the fins. Remember, the fins are cupped like that. If there's any dirt in those cups, then the fan will not throw the air properly. So if this is dirty, if this blade happens to be dirty, perfect time to take this outside, wash it down. You can actually take this apart further. You can, there's two screws here. This little plate here will come out. If you were to remove the motor, undo the shaft, remove the motor, this wheel will come right out. This motor can come right out. This motor obviously might need to be repaired at some point. Well, the other thing to look at while this is out is, are there any points of lubrication on this motor? If this motor was a lubricating style motor, there would be little pins here, one here and one at the other end in the end bells. Generally they're yellow plastic, or they could be silver aluminum filling a hole. If this motor, if it was able to lubricate the motor, it would pull those little plugs out, put a few drops of oil, motor oil, not engine oil, motor, electric motor oil in those holes, put the cover back in again. Never over oil motors. It's better to under. This is a sealed motor, so you don't even have to worry about it. It runs till it fails and then you replace it. So that's pretty much that. I'm going to put this back in. A little trick that I have learned over the years is, if you have a piece of lumber handy, it does help to have that in there. You have to hold the blower up for a minute or two, or not, maybe not even that long, but in order to get these screws back in, you have to hold the motor up. Sometimes a little bit of leverage helps to do that. So, try that. Actually, maybe I will have to put that in after, if the blower's not fitting in with that in there. So we're going to slide this back in. There will be a track that this blower has to go in. So I don't know if you can see up in there, there's two lips that the blower rails will actually fit into. So you put that in, you slide it. This metal clip here is actually what was holding the limit switch, so you have to get past that. There's two stops, you can only push it in so far and then it stops. And then I have two screws that I need to put back in again. This is where this actually helps to hold that up. Trick is getting it lined up. There we go. There's one. one started. That one up. Another screw. That one started. There. And 2x4 out. Now I'm going to reconnect my wires. Let's maybe start with the limit switch. It has to go back under the clip. There, limit switch is back in place. Oh, maybe not. There. Oh, there, I didn't have that in tight enough. There we go. Limit switch is in. White wires on the neutral. One. There was another white wire. Until maybe I put them all out. My red and black harness plugs on there. Can only go one way. This harness with all the wires, those are on there. You can't do it backwards, it won't go. My 24 volt on the transformer. I have a black that went at the top to the L1. And I believe that is all the wires connected. We're good to go. So that's blower removed, blower replaced. All good to go. I think that's pretty much everything. So there we go. Service. Removing and replacing the burner. Removing and replacing the induced draft motor. Removing and replacing the blower. Looked at a few of the other components. So electrical class, you're going through some troubleshooting, how to check switches in series, how to check switches in parallel. This is where you would use that. If you're troubleshooting, this is where you need to know that stuff. So anyways, hope that helps. We're going to do one more video later going through maintenance, so we'll do that a little bit later. So hope that explains a lot to you about how to service furnaces, how to remove, reassemble, do all kinds of stuff with the furnace. So anyways, till next time, thanks, and we'll see you next video.